So today I'm going to show you three other examples involving these square roots. So yesterday you looked at some examples where, we had a square root set equal to a constant. Again, we kind of referred back to that skill probably happened back in Algebra 1. Hopefully you got into the rhythm of, double checking to see if your answers were true. We looked at that special case of where it could not be set equal to a negative. So one thing that could happen when we're dealing with these square roots is something called an extraneous solution. Okay, and in math, what an extraneous solution resorts back to means an answer that doesn't truly satisfy our equation. Okay, so I'm going to show you a couple of examples here. I've got three examples. I'm going to show you what happens when we get an answer, but it actually doesn't work. Okay, and like I said, those are referred to as extraneous solutions. So first example here, notice how, again, we have a square root set equal to a variable. It doesn't change the scale of what we talked about yesterday. It's just going to add a little bit more steps to us here. Okay, so remember the skill we talked about yesterday where how we see a square root, we get rid of this square root by squaring. Remember, squaring and square root are opposite operations. So I've got to break out this square root, but in order to do so, right, like we talked about yesterday, I've got to square both sides. Okay, now when I squared this square root, right, that square root's going to go away. But now, right, when we square x squared, right, we have an x squared. Okay, so yesterday we dealt with a lot of linear equations. Notice how everything had a power of 1. Now when we square both sides that has a variable, is going to turn a variable into a quadratic here, right? We have an x squared, which is our quadratic. So again, a couple chapters ago, we talked about, a variety of ways to solve these quadratics. We talked about how to solve by factoring, solve by taking square roots, solve by using quad formula. But remember, the big skill here, we've got to get it set equal to a 0. Okay, so everything that's on the left here, I'm going to go ahead and move over to the right. Right, it's a lot easier when the x squared term is happy, he's positive. And then I'm left with this guy right here. Again, now you have your quadratic. It's personal preference. Do you want to factor? Do you want to use quad formula? We can't take the square roots because of that b term. To me, this guy should be easily factored. What multiplies to get 4, but adds to get -5, -4, -1. So your factors are x minus 4, x minus 1. Sorry, shaking the camera. Which tells me that x is 4 and x is 1. Okay, so those are the two solutions. That is what should satisfy our equation. Again, dealing with these square roots, you've got to go back and check to see if it actually made it work. Okay, so if I put 4 back in, 5 times 4 is 20. 20 minus 4 is 16. So I have the square root of 16 is equal to, remember, a solution of 4. Well, the square root of 16 is 4. So yeah, this is a true solution. That will satisfy our equation. Let's see what happens with the 1. Well, if I put 1 in for x, 5 times 1 is 5. 5 minus 4 is 1. So that means I have the square root of 1 is equal to x being 1. Square root of 1 is 1. So actually, this guy here, the extraneous solutions did not take effect. Those were two real solutions that we were able to find. So a lot of this definitely resorts back to those quadratics. You've got to be able to solve quadratic stuff. All right, so like I said, we got two more examples here. Same exact setup. You've got a square root set equal to a variable. The only way we can get rid of this square root is by squaring. So I'm going to go ahead and square both sides. Okay, so that's going to leave me with the -2x plus 80 is equal to an x squared. Okay, so you got the same drill going on here. You've got a quadratic. The only way you can solve quadratic, factoring and formula. So I'm going to go ahead and move everything to the right. So I've got an x squared, now plus 2x minus 80. Just so you can see that was on the right. All right, again, my factoring skills are stronger, so I usually resort to factoring, especially seeing, the a value is 1. If you like the quadratic formula, use it, but definitely be careful. A lot of you guys are sending in work, and just because you're substituting the numbers in, you need to make sure you're simplifying correctly. Okay, so here's my diamond. What multiplies to get -80? Add to get positive 2. It should be a positive 10 and a negative 8. So those are my factors, right? X plus 10, x minus 8. This guy tells me I have a solution at negative 10. This guy tells me I have a solution at 8. Okay, so watch what happens when I go ahead and substitute these guys back in. I'm going to start with the 8. Okay, so negative 2 times 8 is negative 16. Negative 16 plus 80 is 64. So we have the square root of 64 equals, we said x is 8. Well, square root of 64 is 8. Okay, watch what happens with this guy. Okay, so when I put in this negative 10, oh, it looks like red. What color have I not used? Sorry, it's light blue. So look what happens when I put this guy in. Okay, negative 10 times 2 is a positive 20. 20 plus 80 is 100. So I have the square root of 100 is equal to, remember x is negative 10. Well, the square root of 100 is 10. Right? This is not a true statement. It does not work. This is called, this here, right? This guy here is extraneous. Okay, so it's an answer, right? We solved for a value, but it does not satisfy our equation, okay? So when those come across, right, you've always got to double check your answer. When we come across those guys, those are referred to as your extraneous solutions, okay? And when you see these radicals, you know, you're asked to solve equations with radicals, you're going to come across those from time to time. And one other example, you know, what happens if it's set equal to another radical? As we can see, again, it doesn't change the game, right? We've got a radical on the left, we've got a radical on the right. We need to get rid of them. Well, the only way to get rid of a radical is to square root it. So this actually kind of makes it pretty simple here. So we're going to just square both sides. Squaring both sides takes care of the square roots. Okay, so now you have a linear equation, right? The squares are gone, so you don't have a quadratic to deal with. So this should be, I don't know, like a two-step problem here. I'm going to take the x's away, so the x's stay positive. And I'm going to add 7 to both sides. X is 12. Again, double check to see, you know, this may be an extraneous solution. Just plug it back in and see what happens. Well, x is 12. 12 plus 5 is 17. So we have the square root of 17. We don't know what that is, but I don't think it's going to matter here. 2 times 12 is 24. 24 minus 7 is also 17. So it doesn't matter what the square root of 17 is because it's also equal to the square root of 17. Okay, so I know these are quick examples here, but you know it is on camera. You can refer back to if you're struggling with it. The assignment for today is not going to be on Delta Math. It's just going to be through a worksheet. You don't have to submit any work through it, but I will show you answers to make sure you're understanding what is going on.